Graphing quadratic equations. Suppose you were asked to graph the following equation. Y is equal to x squared plus 8x plus 15. First thing you should try to do is get it in what's called standard form. That is, complete the square. Basically, isolate that constant. Now, what I want to do is figure out what I add inside. Half of this is 4, and when you square it, you get 16. So I'm adding 16. But I can only really add 0. From this line up here to our new line, I can only add 0. So if I'm adding 16, in fact, 1 times 16, I have to take away 16. Because now I'm just adding 0. So what's inside those brackets is now a perfect square. It's x followed by half of that, which is plus 4 squared. And if you add 15 and you take away 16, you took away 1. If you put $16 in the bank, that is, you add $16, and then you go back later and you take out $16, well, you took out $1. You picture the $15 in your hand. You give it to the teller, and then later on, the teller gives you $16. Think of it as 15 and 1. The first 15 is the 15 you gave her. That canceled out. You give the teller 15, they give you back 15, that cancels out. So as if it never happened. But then the teller gives you an extra $1, so you took out 1. Alright, so y is equal to this. What you want to find out is the vertex. The vertex, just like any other point, has an x and a y value. The x value is what makes that 0. What makes x plus 4 equal to 0? I mean, you have some number and you add 4. 1, 2, 3, 4. You add 4 and you get to 0. Well, that number is negative 4. So the vertex, the x value is negative 4. The y value is easy. You just read it off. It's negative 1. In fact, the x value, as long as this is x and not 3x, the x value will be that number with a sign change. Positive 4, the x value is negative 4. So basically, you go to negative 4 and down 1, you go right here. And since the original graph, the original equation, as I wrote on it, let me write it again. It was positive x squared. What that tells me is this graph is going to open upward. The question is it like I just drew, or let me draw it more symmetrical? Is it this graph right here, somewhat wide one? Is it a narrow graph? Is it extremely wide? Is it extremely narrow? Well, if we had one more point, we can figure that out. One more point would give us that information. For example, what's the x-intercept? The x-intercept is when the y value, let us find the y-intercept. The y-intercept is when not y, but the other letter, x, is 0. Well, 0 squared is 0. 8 times 0 is 0. Add them, get 0. Add 15, and you're going to get that number, 15. That tells me, given that this distance is 1 down here, given that that distance is 1, because that's why I put negative 1 there, I have to go up 15 of them, say way up here. And there is your graph. It's fairly narrow. And you really should put the y-axis. find the vertex and one other point. Generally the y-intercept is good. The only time you won't use the y-intercept is in a case as follows. If the vertex was on the y-axis, well then what am I going to do? Get the same point again? So, I don't know if it goes like this, if it should be fairly narrow, should it be really wide? I don't know these things. So I would need one more point. That would be the only time I wouldn't use the y-intercept. In fact, I would be using it. I would be using it as a vertex. Suppose you were told that y is equal to x squared plus 2x take away 3. Well, isolate that negative 3. That is, put everything else in brackets. Take half of that number, take half of 2, then square it. Half of 2 is 1. You square it, you get positive 1. So you add 1, then you have to take away 1. Now, what's inside these brackets is something squared. What's squared? X followed by half of this number, plus 1. Take away 3, take away 1, you took away 4. So the vertex, what makes that 0? Negative 1. Negative 1 plus 1 is 0. What does this say? Negative 4. So that's the vertex. The y-intercept, that's when x is 0. It's always going to be the constant. It's easier to find the y-intercept when it's in this form, not this one. If you want to use this one, it's harder. You have to go 0 plus 1 is 1, square it is 1, 1 take away 4 is negative 3. Personally, I'd rather just read off that number on top. So now we have everything we need to know. The y-intercept is where x is, the vertex is where x is negative 1 and y is negative 4. It crosses the axis, the y-axis at negative 3. X, y. So armed with those two pieces of information, the lowest point, which is the vertex, and the y-intercept, we have it. And since the number in front of x squared was a positive number, it's positive 1, that's why it opened upward. But the other thing is, if you know this is the lowest point, you know that's the vertex, which is either the lowest or the highest point. If it goes this way, it's the highest point. If it goes this way, it's the lowest point. Now, if you have another point over here, well then it has to open up. If that other point was not here, but rather down here, well then she opens downward. Okay, 2 points is enough to graph these. A lot of teachers out there will say plot 10 points and then connect the dots. And sometimes that may not work. For example, if these were the 10 points, and I'm not going to count how many I drew, but I will say I don't know how this one got there. Now, actually, well, these are the 10 points. These are a number of points that you have. Well, the thing is that does it come down a lot further and then start going up? Does it start going up pretty much immediately? That didn't look like a smooth transition, but it could have been. Okay, so plotting a lot of points may not help. Suppose you were asked to graph y is equal to negative 2x squared minus 6x plus 4. What I would do is isolate these two terms with the constant. And then I factor out the negative 2. Negative 2 times x squared gives you negative 2 times x squared. Negative 2 times positive 3 gives you the negative 6 times an x gives you negative 6x plus 4. So I want to know what number I write in there. Well, it's going to be half of 3 squared, which is 3 over 2 squared, positive 3 over 2, which is 9 over 4. So I write in 9 over 4. But is that what I really added from the second line to the third line? The answer is no. I added negative 2 times 9 quarters. 2 goes into the top number 1 time, 2 goes in this bottom number 2 times. You have negative 1 times 9, which is negative 9 over 2. That's what I added or subtracted. Since I took away 9 over 2, I have to add in 9 over 2. Okay, let's get rid of some of this side work. So now I have negative 2, and what's in the brackets is something squared. Okay, what's in the brackets is something squared. It's x followed by half of the number in front of x, which happened to be 3 over 2 squared. Now, 4 plus 9 halves, well, that's 4 and 9 halves. 8, multiply, get 8, plus 9 is 17. 17 halves. Okay, so what is the vertex? Well, what makes this 0 is negative 3 over 2. What this says is 17 over 2. And the Y-intercept is at 4. Positive 4. At 0, 4, or just 4 is okay. So we come and we graph this information. X is negative 3 halves. Y is, remember, that's 8 and a half. So 1, 2, 4, 6, 8, 10. So 9's about here, so 8 and a half is right there. So it's negative 3 over 2, 8 and a half. And it crosses the y-axis at 4. And remember, that's either the high or the low. Okay, it can't be the low because that point would be lower. It's the high. It goes this way. And the fact that the number in front of x squared was negative, that's why it goes upside down. It opens downward. Now, this is one way of doing these type problems. There's another way of doing it. My opinion is less friendly, but it's another way of doing it. So let's look at it. Suppose you have y is equal to x squared minus 6x plus 4. The x value of the vertex, the x value, I'll put a little v down there to stand for a vertex. The x value of the vertex is negative b over 2a. Remember, the number in front of x squared is a, the number in front of x is b, and the constant is c. So we get negative b, which is negative 6, divided by 2 times a, which is 1. We get 6 over 2, which is 3. So we found the x value of the vertex, but now we have to go back and find the y value. That's why I don't like this one so much. y is equal to x squared minus 6 times x plus 4. Write x the way I've been writing them. Write x this way. And then if they tell you x is 3, fine, you plug 3 in. 3 squared is 9 minus 6 times 3 is 18 plus 4. 9 take away 18 is not 9. 9 take away 0 is 9. Imagine you have $9 in the bank, and somehow you convince them to let you take out $18, and now you have 9 left. If that was the case, I'd say, give me another 18. Because it's like taking out nothing. You still have $9 left in the bank. Yet, you have $18 in your hand each time you ask them, you know, that $9 I have in the bank, give me 18. In fact, 9 minus 18 is negative 9 plus 4. If you owe somebody $9 and you give them 4, you owe them $5. So the vertex is x, y. 3, negative 5. The y-intercept is at 4. It's at 4. Okay, so you go to where x is 3, 1, 2, 3, 4, negative 5. Here is your vertex. Okay, 3, negative 5. And the y-intercept is fairly high. I was surprised about that. I thought it was negative 4 for the moment. It's up here. Okay, so here's your graph. It's a narrow one. Teacher's not going to take out a ruler and make sure it's completely symmetric. But I would definitely mark it somewhat wrong, take some points off if the right half you drew like that. Like, why is the left half fairly narrow and the right half wide? Now, where is the halves I'm talking about? Here is this imaginary line. What you draw to the left of that line should be the mirror image of what you drew to the right of that line. Okay, this piece here and this piece here, they should be mirror images across this line. Called the line I just drew. This line is called the axis of symmetry. Okay, let's try one more. Suppose you were told y is equal to negative 2x squared minus 6x plus 4. The x value of the vertex is negative b divided by 2 times a. b is what's in front of x, and a is what's in front of x squared. And you get positive 6 over negative 4. A positive over a negative is negative, and 6 over 4. You can reduce the top and the bottom. You can divide the top and the bottom by 2, you get 3 over 2. This number divided by 2 and this number divided by 2. Or 2 goes into 6 3 times and 2 goes into 4 2 times. Now here is where I really don't like using this technique. Now we have fractions. Top being this top line, except instead of x I will put brackets. Y is equal to negative 2 times x squared minus 6 times x plus 4. X is negative 3 over 2. It is what it is. Negative 3 squared divided by 2 squared. A negative 6 times a negative 3 over 2 is going to become positive. Okay, so I know the sign now is positive. And 2 goes into 6 3 times. 3 times 3 is 9, plus 4. Okay, 2 goes in here 1 time, 2 goes in here 2 times. Negative 1 times 9 is negative 9 over 2. Plus 9 plus 4 is plus 13. But I'm motivated to write 13 as 26 over 2. 13, bottom right. 13 is 13 over 1. But I want to write it with a 2 in the bottom. So I multiply the top and the bottom by 2. Why do I want a 2 in the bottom? So it matches the other fraction. In addition, if the denominators are the same, and they are, keep it. Add the numerators. You owe somebody $9 and you give them 26. Well, the first 9 you gave them brought you to 0. 26 is 9 plus 17. You owe somebody $9, you give them $9, you're at 0, and you give them 17, you're at 17, which is 8.5. So we have the vertex. We have the x value, and we have the y value. The x value is negative 3 over 2, and the y value is 17 over 2, 8.5. 17 over 2. So there is your vertex. I know I'm right, because when I look down, I see the right x value, and when I look across, I see the correct y value. And the Y-intercept is at 4. This is 8.5, so maybe 8's right there, 4 is right there. The cross is right there. And the vertex is either the high or the low. It can't be the low because I just put a point lower. That Y-intercept is lower than the vertex. So the vertex must be the highest point. If you go like that, in my opinion, somewhat wide, you have to go the same way in the other direction. That is, this imaginary line hit the left half, to the left of the line and to the right of the line should be the same. That is, if you were to put, say, red paint on here, and maybe this was drawn on paper, and you fold the paper along this imaginary line, this red paint will now be right here. Because when you fold the paper, it's going to transfer from one side to the other. Okay, now, that would be the exact answer. If you drew something like that, that'd be okay. If you drew that, that'd be okay. If you drew this, I'd take off a couple of points. That's way, way off. If you drew something like that, you'd lose some points if I were grading your paper. Because that's your way of screaming out to the teacher, I don't know that the left half of that imaginary line and the right half of that imaginary line should be the same. In which case, you really do deserve to lose a couple of points. Okay, that pretty much finishes this section. Good luck with it.